Well, hello guys, here Mr. G with another video. This time we're going to be doing some questions, two questions in actual fact about generators than in the previous video for grade 12. This is related to electrodynamics. So the first question we're going to solve is this one here, and the question say, the diagram below shows a basic electrical generator or electric generator. What type of general AC or DC is illustrated above? Give a reason for your answer. Now, when you identify between the AC and the DC generator, you have to look for two things. The AC have the slip rings and the DC will have the split ring. Okay, that is the difference. The slip rings, there are two. It may help to say that. There are two slip rings, okay? But the split ring is only one. Is only one. So this one may help you to identify. So if we look at this one here, you can see that at this specific point here, there is only one ring. This one is, guys, the DC generator. DC generator. Why you have to say? Because it have split ring. That is the answer for that question 1.1. 2 marks for saying that. Okay, now is the induced potential different in the coil illustrated above to increase or decrease? Now if you see, look carefully to the picture, this motion, this is coming up, is moving up. Let's use another color. I like colors, guys. I like colors. This side here is coming up and this side there is coming down, so it is going to be in position. If we go back all the way to the previous lesson, it is going to be moving to this position here, which is a zero potential difference. It is moving towards that position we learned in a previous video. Won't watch the video if you didn't. Okay, so if you look carefully, it is moving towards that position, so it is about to decrease. So what we have to say is about to decrease, is going to decrease. Now what happened there? Remember, when it's in the horizontal position relative to the pole of the magnet, all the magnetic flux is being cut. So there's not, all the magnetic flux is passing through, but it's been cut already. So that is what you have to actually say there. For 5 marks, you have to explain all that in details, like we did here in the previous lessons, step by step. Okay, so you have to explain that one. That is why it's so many marks. Also remember, this is an old question that they used to give a lot of mark for that explanation. But what you have to say, it is about to decrease. We can, let's write here what you can say in words. Okay, so first we can say that the horizontal position, in the horizontal position, all the magnetic lines are passing through the coil. That is important. You can say it. You can say it in that word, or you can use any other English word or explanation you want. But what happened? This is not what produces the EMF and therefore the current. What produces that one is the change in magnetic flux. And at that position, the change in magnetic flux is at minimum. The change in magnetic flux is at minimum. This is just a small explanation of what happening at that specific point. State one change that can make the above generator to increase the output potential energy. How can we produce more potential energy and therefore more current in this specific small generator? That is the final part of this question. And this one is question 1.3. Let's do it here. 1.3. There is 3 things we can do there very easy. Very easy. First of all, we can speed up the rotation or increase the speed of rotation. So if we move faster the coil, then more potential difference will be generated there, will increase. Okay. Second, increase the number of wire loops in the coil. And lastly, we can use a stronger magnet. Okay, we can use stronger magnet. To write it here because we are done. And this is the end of the question, guys. This is very easy to take marks in this topic. This is this first question 1. I hope you understand. Let's do question 2 and then we are done with this short video. The sketch below shows the operation of an alternating current generator. So they are telling you it is an AC generator, and you can see that in A you have two rings, as we spoke before. Here to identify, I say you have two if it's slab rings. Okay, you can see two rings there, and then if we can even write here, the question is going to be, we can write this one is slab rings. That is component A that they're going to ask you just now. Question 2.1, name the parts label A and B. So that one is the slab rings, and B would be the carbon brushes. That is A and B. This one is carbon brushes. Carbon brushes. Those are the two parts, A and B, that they speaking about. In which direction does the segment PQ on the coil have to rotate in order to cause the current direction as shown in the diagram? Write down clockwise or anti-clockwise. The current is going from P to Q. Guys, for this one you have to use the right hand rule. Okay, so they're telling you write down clockwise or anti-clockwise. You have the current and you have the magnetic field. So let's do the following. You select one side of the coil, any side, and then you are going to place your hand in such a way that, first of all, the pointing finger is pointing in this direction. Why in that direction? Because the pointing finger will indicate the direction of the magnetic field from north to south. Okay, this is the magnetic field and is the pointing finger. So that one is going to be the pointing finger, or index finger to use the correct term there. So the index finger is going to be pointing in that direction there. So you make sure you do that. Now the direction of the current, which is already a black arrow, they show what is that one. That one is going to be the middle finger. So you make sure you place the middle finger in this direction there. It is not difficult. Okay, so now the problem is here, the middle finger, you cannot turn it so in the exactly direction of that black arrow, but you can show that is indicated towards the book. So that one will be the middle finger. That one will be the middle finger in that direction is the current. And then the thumb, which is going to be pointing the right angle to the middle, and the index is going to represent the motion of the coil. So the motion of the coil, this one is the thumb, and the motion of the coil, this one is motion. Guys, you can see then that this is going to be clockwise. The direction in which this specific coil is moving is clockwise. That one is quite simple. Remember, it's only one mark. Don't stress about that right hand rule, but it's easy to get that mark though. It's not a big problem. Write down two changes that can be brought about to improve the output of the generator. Guys, this one we are not going to answer is here. I just fixed this letter number was written completely wrong. I don't even know what word was that, and I just fixed it. This one here is the answer for that question. The changes you can make to improve the generator, to make the generator to work better. Remember, when we say generator to work better, all we're speaking about is to produce either a greater EMF, a bigger current. That is the purpose of the generator, guys. So this one is that question. I'm not going to write it. Call them, watch the answer. That is quite simple. What changes must be made for the AC generator to make a function as a DC? We have to change the slip rings for split ring. So change the slip rings for split rings. There we go. If we do that, we're changing the generator from an AC to a DC. Okay, so that is quite simple, guys. The induced EMF versus times graph for AC generator is shown below. Sketch a graph to show how this one will change. Very simple. We've done it before. Let's do it here in this side here at the bottom. So let's have the axis in which this one is the EMF. This is the graph, the one. This one is the X with the time. Now, what is going to happen here? The potential difference also, or the EMF, is going to increase. This is induced EMF. It's going to increase all the way, and the curve must be curved straight, not like that. Okay, there we go. So it's going from minimum to maximum to minimum, but it doesn't change direction. It go again to maximum to minimum and so on. That is the cycle. The cycle. The only thing is it doesn't change direction. This one is the graph for a DC generator. And guys, this is the end of the video. I hope it helped. If it did help, thumb up, subscribe for the channel. I'll see you next time with more videos. Mr. G here.